if you put your mind to it, you can achieve anything. This iconic quote from Back to the Future isn't just an inspirational motto from Marty McFly. It encapsulates the spirit of one of humanity's greatest dreams: time travel. In the film, Marty and the eccentric Doc Brown defy the laws of physics with a modified DeLorean, embarking on adventures that show how fascinating and dangerous it is to mess with the past. But as we watch, Marty tried to right the wrongs he caused by interfering in the past. An inevitable question arises. What if this were possible in real life? Could we go back in time to correct our mistakes or change the course of history? Or could it be that, as in the film, any small change in the past would create catastrophic consequences in the present? What makes Back to the Future so brilliant is that it not only entertains us, but also makes us reflect on the paradoxes of time. If you went back to the past and changed something, like stopping your parents from meeting each other, would you still exist? And if it didn't exist, who would have gone back in time to cause this change? These questions are not just fiction. They touch on one of the greatest mysteries of modern science: time. Is it a straight line, as we always imagined, or can it be bent, manipulated, and even rewritten? And if we can truly travel to the past, are we ready to deal with the consequences? Traveling through time is one of the most fascinating concepts ever imagined by humanity. From the first science fiction tales to the most iconic films, such as Back to the Future, the idea of manipulating time intrigues us because it touches on something deeply human: the desire to correct mistakes, relive moments, and, perhaps, change destiny. But while fiction entertains us with cars that travel at 88 miles per hour and synchronized clocks, science presents us with a much more complex and, perhaps, impossible challenge. The biggest obstacle to traveling to the past is what we call the temporal paradox. One of the most famous examples is the grandfather paradox. Imagine that you go back in time and prevent your grandfather from meeting your grandmother. If that happens, your parents would never be born, and consequently, neither would you. But if you weren't born, how could you have gone back in time to prevent the meeting? This kind of contradiction is what makes traveling to the past so problematic, at least from a logical point of view. And it's not just the grandfather paradox. There are other equally intriguing dilemmas, such as the information paradox. Imagine that you go back in time and give a scientist from the past a revolutionary formula that he would never have discovered on his own. He publishes the formula, and it becomes famous. Years later, you learn about this formula and decide to go back in time to give it to the scientist. But in this case, who actually created the formula? It seems to appear out of nowhere, without a clear origin, an infinite cycle of cause and effect. These paradoxes are not just exercises in logic. They raise profound questions about the nature of time and reality. Is time really linear, like a straight line from past to future? Or is it more like a river, which can be diverted, bent, or even divided into multiple flows? And if we can alter the past, will we create a new timeline, a parallel universe, or simply erase the present as we know it? Modern physics tries to answer these questions, but the answers are as mysterious as the concept of time itself. Albert Einstein's theory of relativity showed us that time is not absolute. It can be dilated or contracted depending on speed and gravity. This means that, in theory, traveling to the future is possible, but the past is a different story. To go back in time, we would need something that defies the known laws of physics, like a wormhole, a kind of shortcut in space-time that connects to distant points. Wormholes are fascinating because, in theory, they could allow time travel. Imagine you go into a wormhole and come out the other side at a point in the past. Sounds simple, right? But there is a problem. The energy required to stabilize a wormhole would be so immense that, as far as we know, it is impossible to achieve. Furthermore, even if we managed to stabilize it, the temporal paradoxes would still be there, waiting to challenge us. Another intriguing theory is that of the multiverse universe. According to this idea, every time you change the past, you create a new timeline, a parallel universe where things happen differently. This would resolve the grandfather paradox, because by preventing your grandparents from knowing each other, you would not erase your own existence. Instead, you would create a new universe where you were never born, while the original universe remains intact. But if that's true, it means we could never truly change the past, only create alternative versions of it. And then there's the philosophical question. Even if we could travel to the past, should we? History is full of tragic events we would like to avoid. Wars, natural disasters, personal losses. But by trying to correct these events, wouldn't we be interfering with something bigger, something we don't fully understand? After all, as we saw in Back to the Future, even the smallest change in the past can have unpredictable consequences in the present. These questions are what make the time paradox so fascinating. It's not just a scientific problem, it's an existential dilemma. It forces us to confront our own limitations, question our understanding of the universe, and imagine a future where the impossible can become possible. The idea of time travel may seem modern, but in fact, it is as old as humanity itself. Since the first myths and legends, human beings have always asked themselves, is it possible to return to the past or move forward to the future? This curiosity isn't just scientific, it's deeply rooted in our culture, our philosophy, and even our dreams. The first concepts of time manipulation appear in ancient mythologies. In Hindu mythology, for example, there are stories that suggest a non-linear perception of time. A famous tale tells of King Kakudni, who traveled to the kingdom of the god Brahma to ask for advice. When he returned to Earth, he discovered that thousands of years had passed, a clear example of time dilation, long before Einstein formulated his theory of relativity. In Greek philosophy, time was also a central theme. Heraclitus believed that time was like a river in constant flow, while Parmenides argued that time was an illusion, an idea that resonates with some modern interpretations of quantum physics. These philosophical debates have not only shaped our understanding of time, but have also inspired generations of thinkers to imagine what might be possible if we could manipulate it. However, it was in literature that the idea of time travel really came to life. One of the first examples is the short story Rip Van Winkle by Washington Irving, published in 1819. In the story, the protagonist falls asleep for 20 years and wakes up in a completely different world, having traveled to the future without realizing it. But it was in 1895, with the publication of The Time Machine by H.G. Wells, that the concept of time travel as we know it today was actually popularized. Wells not only introduced the idea of a machine that allows time travel, but also explored the social and philosophical implications of this journey, laying the foundation for modern science fiction, while literature and philosophy explored the concept of time in an imaginative way. Science began to approach the topic more rigorously at the beginning of the 20th century. Albert Einstein's theory of relativity, published in 1905, revolutionized our understanding of time and space. Einstein showed that time is not absolute. It can be expanded or contracted depending on speed and gravity. This opened the door to the theoretical possibility of time travel, at least into the future. But what about the past? This is a much more complicated issue. While the theory of relativity allows for time dilation, meaning that by traveling close to the speed of light, you could fast forward into the future, going back to the past requires something much more exotic, like wormholes or sharp curves in space-time. These ideas, while fascinating, remain in the realm of theory, with no experimental evidence to support them. Despite this, the idea of time travel continued to capture the public's imagination, especially through film and television. Back to the Future, 1985, is perhaps the most iconic example. But it is not the only one. Films like The Terminator 1984, Interstellar 2014, and series like Doctor Who explored different aspects of time travel, from paradoxes to emotional and ethical implications. What makes these stories so powerful is that they're not just about science, they're about humanity. They force us to confront our choices, our regrets, and our desire to control the uncontrollable. Because at the end of the day, time travel isn't just a question of physics. It's a question of who we are and what we want to be. Today, science continues to explore the mysteries of time, but we are still far from building a DeLorean that can take us to the past. However, the simple fact that we are asking these questions and trying to answer them shows how far we have come. Because, as Doc Brown himself said, the future is not written yet. Your future is what you make of it. Although the idea of time travel still seems like something out of a science fiction movie, modern science has made impressive advances that bring us closer, at least theoretically, to understanding how time works, and, who knows, even manipulating it. These advances not only challenge our understanding of the universe, but also show us that the impossible may be closer than we imagine. One of the greatest milestones in the exploration of time was Albert Einstein's theory of general relativity, published in 1915. This theory revolutionized our understanding of space and time, showing that they are not separate entities, but rather part of a single fabric called space-time. Einstein demonstrated that space-time can be curved by gravity, meaning time can flow differently depending on where you are in the universe. This phenomenon, known as temporal dilation, has already been proven in real experiments. For example, in 1971, scientists Joseph Haffel and Richard Keating performed a famous experiment. They placed atomic clocks on planes that flew around the world in opposite directions. When the clocks were compared to those on the ground, there was a difference. The clocks on the planes were behind those on Earth. This experiment confirmed that time actually passes differently depending on speed and gravity, as predicted by Einstein. But what does this mean for time travel? Well, time dilation shows us that traveling to the future is, theoretically, possible. If you could travel close to the speed of light, time for you would pass much more slowly than it does for people on Earth. This means that when you return, you would have traveled into the future. This concept was brilliantly explored in the film Interstellar 2014, where the protagonist experiences time dilation when orbiting a black hole. Speaking of black holes, they are another fascinating element in the quest to manipulate time. According to the theory of relativity, black holes are regions of space where gravity is so intense that even light cannot escape. But what makes black holes even more intriguing is that they can warp space-time in extreme ways. Some scientists believe that if we could survive the crushing gravity of a black hole, we could use it as a kind of shortcut to the future, or even the past, if it's connected to a wormhole. Wormholes, in turn, are one of the most exciting and controversial ideas in modern physics. First proposed by Einstein and Nathan Rosen in 1935. Wormholes are theoretical tunnels that connect to distant points in space-time. In theory, they could allow instantaneous travel between these points, which would include traveling to the past. However, there is a big problem. To stabilize a wormhole, it would be necessary to use an exotic form of matter with negative energy, something that, until now, only exists in theory. Another fascinating advance comes from quantum physics, which deals with the behavior of subatomic particles. One of the most intriguing concepts in quantum physics is quantum entanglement, where two particles can remain connected regardless of the distance between them. While this isn't exactly a form of time travel, some scientists believe entanglement could help us better understand the nature of time and even open doors to new forms of temporal manipulation. Additionally, recent experiments have explored the idea of closed time curves, which are trajectories in space-time that allow an object to return to its starting point in the past. Although these curves are purely theoretical, they raise fascinating questions about time paradoxes and how they could be resolved. For example, some scientists suggest that if closed time curves are possible, the universe may have natural mechanisms to avoid paradoxes, such as preventing you from directly interfering with the past. But while science advances, there are still many challenges to overcome. The energy required to create a wormhole or manipulate space-time is unimaginably high, and temporal paradoxes remain a logical obstacle. Furthermore, even if we were able to travel through time, the ethical and philosophical implications would be immense. Should we interfere in the past? And if we do, what would be the consequences for the present and the future? Despite these challenges, the quest to understand time continues to inspire scientists, philosophers, and dreamers. Because at the end of the day, time travel isn't just a matter of physics, it's a matter of imagination. And, as Back to the Future taught us, if you put your mind to it, you can achieve anything. As fascinating as the idea of time travel is, it is also surrounded by controversies, paradoxes, and even fraud that call into question its viability. While modern science offers us intriguing theories, it also reminds us that time is one of the most complex and, perhaps, unattainable concepts we have ever tried to understand. And, throughout history, the search for answers about time has generated not only advances, but also confusion, heated debates, and even scandals. One of the biggest obstacles to time travel is logical paradox. As we mentioned earlier, the grandfather paradox is a classic example. If you went back in time and prevented your grandparents from knowing each other, you would never exist. But if you didn't exist, how could you have gone back in time to cause this change? This kind of contradiction is one of the biggest challenges to the idea of traveling to the past, and even the most brilliant physicists have trouble finding a solution. Some scientists suggest that the paradoxes can be resolved through alternative time. According to this theory, every time you alter the past, you create a new timeline, a parallel universe where things happen differently. This means that by preventing your grandparents from knowing each other, you would not erase your own existence, but you would create a new universe where you were never born. However, this idea raises another question. If there are infinite timelines, how can we know which one is real? And, more importantly, how could we travel between them? In addition to the paradoxes, there are also technological limitations. While theories like wormholes and closed time curves are fascinating, they require levels of energy and technology that are far beyond what we can currently achieve. For example, to stabilize a wormhole, it would be necessary to use exotic matter with negative energy, something that, until now, only exists in theory. Even if we were able to create this matter, the amount needed would be so immense that it would make the experiment impractical. But the controversies don't stop there. Throughout history, the idea of time travel has also been the target of fraud and exaggerations that have damaged its credibility. One of the most famous cases is that of John Titor, a supposed time traveler who appeared on internet forums in the early 2000s. Titor claimed to be a soldier from the future, sent from 2036 to recover an IBM 5100 computer, which, according to him, was essential to fix a problem in the future operating system. He made several predictions about future events, including a civil war in the United States and a global collapse, none of which came to fruition. Although Titor's story was debunked as a hoax, it is still remembered as an example of how the idea of time travel can be exploited to deceive and confuse. Another intriguing case is that of Andrew Carlson, a man who was allegedly arrested in 2003 for using inside information to make millions on the stock market. According to reports, Carlson claimed to be a time traveler from the year 2256, which would explain his knowledge of the financial market Although the story was widely reported at the time, it was later debunked as a tabloid fabrication. However, cases like Carlson's show how the idea of time travel continues to capture the public's imagination, even when there is no evidence to support it. In addition to fraud, there are also philosophical criticisms of the idea of time travel. Some philosophers argue that time is a human construct, a way of organizing our perception of the world, and that it therefore cannot be manipulated like a physical object. Others suggest that even if time travel is possible, it may be limited by natural laws that we do not yet fully understand. For example, physicist Stephen Hawking proposed the idea of a chronological safeguard, a kind of natural mechanism that would prevent temporal paradoxes by making time travel impossible. And then there's the ethical question. Even if we could time travel, should we? History is full of tragic events we would like to avoid. Wars, natural disasters, personal losses. But by trying to correct these events, wouldn't we be interfering with something bigger, something we don't fully understand? As we saw in Back to the Future, even the smallest change in the past can have unpredictable consequences in the present. These controversies and challenges show that while the idea of time travel is fascinating, it is also incredibly complex. It forces us to confront not only the limits of science, but also the limits of our own understanding of the universe. Because at the end of the day, time isn't just a matter of physics, it's a matter of philosophy, ethics, and imagination. If you put your mind to it, you can achieve anything. This quote from Back to the Future isn't just an inspirational motto, it encapsulates the human spirit of dreaming about the impossible. And when it comes to time travel, that dream is more than just a fantasy. It is a reflection of who we are, what we desire, and what we fear. The idea of manipulating time fascinates us because it touches on something deeply human, the desire to correct mistakes, relive moments, and, perhaps, change destiny. Who has never wanted to go back in time to undo a wrong choice or enjoy another moment with someone who has passed away? But at the same time, time travel confronts us with impossible dilemmas. Are we ready to deal with the consequences of altering the past? And if we could change the course of history, should we? These questions are not just theoretical. They are existential. They force us to reflect on the nature of time, reality, and ourselves. Because, at the end of the day, time is not just a physical dimension. It is the framework upon which we build our lives. He gives us a beginning, a middle, and an end. He gives us purpose. But what makes time travel even more fascinating is that it's not just a matter of science. It's a matter of imagination. From the earliest myths and legends to today's films and series, the idea of traveling through time inspires us to think beyond what is possible. She reminds us that no matter how far we advance, there will always be something more to discover, something more to dream about. And maybe that's what makes time travel so powerful. It's not just about the past or the future, it's about the present. She reminds us that while we cannot change what has already happened, we can shape what is to come. Because, as Doc Brown said, the future is not written yet. Your future is what you make of it. So as we continue to explore the mysteries of time, perhaps the greatest lesson is this. True power lies not in traveling through time, but in living fully in the moment we have now. Because, at the end of the day, time is what we make of it, and what it makes of us.